Hi, this is Liam Crilly, and this session is everything you need to know about QUIC and HTTP3. So let's begin with a little history lesson, or if you like, a brief history of HTTP. We can get into the details. So here's our timeline. HTTP 0.9 arrived in 1991. This was Tim Berners-Lee developed it inside CERN in Switzerland, and it kind of stayed there for a kind of couple of years before it really started taking off all over the internet. It was very simple. It supported just GET, and you might think that that limited its effectiveness or its capabilities, but from as early as 92, and in my case 93, we were able to write simple web applications by passing parameters on query strings, and I spent a lot of time doing this back in the day. Now, although this was hyperlinking and hypertext in 1991, actually the Gopher protocol was the king of hyperlinks and was more popular than HTTP, even though both protocols originated at the same time. So there's a tiny bit of trivia about the early days of hypertext and hyperlinking. And 0.9 was really still quite popular right up until the year 2000 and a little bit beyond, even though HTTP 1.0 came along in 1996, 97, and introduced a lot of additional metadata for HTTP that made it super useful. So now we have methods, we've got post, we can upload files, we have headers, and with headers comes cookies, and this gave browsers a whole new way of making richer web experiences. But 1.0 itself didn't last very long. It was really only around in common use for 2 or 3 years, because there's one thing they forgot. And so with HTTP 1.1, we had keep alive sessions. So before, we had an HTTP connection on TCP, we'd make a request for a resource, we'd get it back, and then we'd open a new TCP connection for the next resource. And as web pages started getting big and comprising multiple images and the early days of style sheets, then this was really quite inefficient and wasn't scaling. And keep alives meant that we could open one TCP connection and just keep firing more and more HTTP requests for every resource that we needed, building big complex web pages. As you can see, the timeline of HTTP 1.1 runs up until the present day and shows no sign of being superseded. But what did happen in 2015 is HTTP 2 came along, and this solved that problem of HTTP 1 having one TCP connection and multiple requests chained together by multiplexing multiple requests and resources, uploads and downloads on a single TCP connection. Now, the reality is that HTTP 1.1 and web browsers actually open multiple TCP connections, but there's only so many you can realistically open, and each of those requires a new handshake, and it's kind of inefficient, doesn't really scale. So HTTP 2 really set out to solve that problem, be more efficient, and does that pretty well. But now we're in 2021, we have QUIC, and we have HTTP 3, we have a third version. So let's get into the details and the differences between them. So here's our HTTP 1.1 stack. We're using IP for connectivity. We're using TCP as transport and for transporting the data itself. We've got an optional TLS layer for encryption, which we're definitely going to find on the internet. And in this diagram, we see that example of a web browser opening multiple connections, hitting a reverse proxy, or it might be a CDN, it could be a caching engine, it could be a big IP, it could be anything. And then forwarding those connections on to the origins to build a full web response in the browser. But it's really these multiple TCP connections that doesn't scale. And you've got essentially a text-based protocol, which is not super efficient. We can compress it, but that adds layers. And although there's beauty in that simplicity, it's became an impact on the experience that not just web apps, but in particular mobile apps were trying to achieve. And that's what HTTP2 seeks to solve. So 2015, the standard was published. We're still using IP for connectivity, TCP for transport, and TLS is technically optional, but really it's all but an essential part of the way that HTTP2 works. And now we've got binary transport, or binary requests. So we've got a single TCP connection, and we're multiplexing all the requests that we need on one TCP connection. And that binary transport means it's more efficient. We've got encrypted headers, compressed headers, and a number of little minor enhancements all the way along just to minimize latency, get more traffic across the internet to your origins. With HTTP3, and this standard is now technically final, but not yet fully published as a standard. So we're right on the edge of that event happening. We're still using IP for connectivity, but this is the more interesting part. UDP is not used for transport. It's used for packetization of the data, but the transport itself, the reliability and the inclusion of TLS is taken care of by QUIC. So we've kind of got a bottom half and a top half of the transport stack with different protocols taking care of each of those things. On top of that, we have HTTP3, which is remarkably similar to HTTP2 in terms of the semantics. What we're really doing is we're swapping out one style of transport protocol for another and solving some challenges that we had with HTTP2 along the way. So in many ways, QUIC and HTTP3, despite this big change from a TCP to a UDP packetization protocol, doesn't really grow the stack, right? It moves areas of responsibility such as TLS, prioritization, queuing into different bits of the overall stack. And so this is our new HTTP landscape. The reality is that we have 3 different HTTP versions that are all going to be around for a long time. And we're going to be dealing with all of these different standards for some time to come. And the reality right now is that it may be quite surprising in that 13% of all websites are already supporting and using HTTP3. Right? So how can that be? We haven't actually published a standard yet. So what's going on? Again, the reality of this is that it's the content aggregators like Facebook and Twitter, the large internet giants, Amazon, Cloudflare, Google, the CDN providers, the cloud providers, and the massive amount of data that flows over mobile apps, YouTube being no exception. They're already using QUIC and HTTP3. They're built into mobile apps themselves, or versions of Chrome or other browsers already supporting it and knowing which sites that belong to Google, for example, already support HTTP3 or their implementation of a draft standard, even though we're not fully published with the final standard. So that's, in one statistic, really shows how much influence of the HTTP landscape is controlled by the big internet giants. And we're left with, on the internet-facing traffic, only 37% of websites only supporting HTTP1. The rest supporting HTTP2, and then a big chunk of those. And this is growing rapidly as we're getting closer and closer to HTTP3 being fully published. But this is a picture of the internet. It's not a picture of the complete reality. Because what we have is HTTP2 and increasingly 3 being the transport of choice and selected by browsers for internet traffic from devices, especially mobile devices and phones, talking to web apps. On an application environment, in a corporate network, in our cloud deployments, really we're still using HTTP1 inside those networks. And this is a very efficient model. And it's not a bad thing, and I don't anticipate us seeing very much of HTTP 2 or 3 actually existing past the edge. gRPC being the exception, as that requires HTTP 2 as transport. And the reason this is totally fine is because the internet and other networks are very, very different. Right? So the internet is highly unpredictable. You could have clients on satellite connections or 3G or LTE connections, and potentially moving around those too. We've got many different types of client. We've got high latency, relatively speaking. There's a good chance of packet loss, and that end user experience is paramount and will take performance over observability any day to make sure that customer experience, the end user experience is top notch. In our application environment, we've got a highly predictable environment, really low latency, super reliable, almost no packet loss, and observability and being able to log things, to inspect, to understand what's going on and just debug stuff is a lot nicer with a plain text protocol over binary protocol. And we'll take that very, very small hit on performance in order to do so. And bear in mind that we've got this edge proxy which is making connections to the origin servers, and it can keep those connections open. There's no handshake to repeat when a new client comes along. And so the problems that are trying to be solved by HTTP 2 and 3, lowering the handshake time, being super efficient, and dealing with packet loss effectively, just don't exist in a typical application environment. And actually using HTTP 1.1 from the edge to the origin servers and the backends is a smart move. So I just want to revisit this timeline. And the standout here, of course, is that HTTP 2 only lasted 6 years, right? So by comparing this to the longevity of HTTP 1, this must be a spectacular failure, right? So it's been already upstaged by QUIC and HTTP3. So before we get onto the details of HTTP3 and QUIC at a deeper level, we need to understand why HTTP 2's reign has been short-lived. So what went wrong? And primarily it's a tale of ambition over adoption. The HTTP 2 standard tried to solve a ton of things, and it really got a bit over its skis in terms of the problems it was trying to solve and what problems were most important and what really weren't. So let's look at these three areas. Firstly, server push. So this is a mechanism built into HTTP 2 which, when I ask for index.html as a browser, the server can send me other stuff too. So it can send me the style sheet and a bunch of images and anything else that I might need or want. But I might not be visiting this site for the first time. I might already have those resources, in which case that was a bad move. And some other challenges there too. 3 years into HTTP 2's life, or halfway through its life, the top 1 million sites on the internet had adopted HTTP 2 pretty well. 25% were supporting HTTP 2. Not even 0.1% were supporting server push or implementing server push, like a tiny, tiny fraction of those most popular websites. These are the people who are the sites, the assets that really care about end user performance. So that is a big chunk of the protocol which is so complex that nobody uses it. Studies have shown that 6 out of 10 times server push might help a little bit. 2 out of 10 times it's neutral, and 2 out of 10 times it actually is harmful. And so you have to really do a whole ton of testing to know whether this is a good thing or not. And the result, don't bother. Prioritization is another super complicated area, and it's really a function of turning HTTP into a transport protocol. We're multiplexing multiple connections, and now the client can ask for additional resources, right? So I'm downloading some stuff. I've got this infinite scrolling on Amazon.com, and I'm scrolling past, looking for things. I'm shopping around, and I'm pulling more images and data back all the time. And the client then is inserting more requests, and it gets to choose what priority these things have. And the server actually gets to choose whether it's going to acknowledge those priorities or not. And this huge kind of tree structure that gets built up of all the resources that are currently being requested at this point in time, stuff getting done and getting removed from the node, the client asking for more stuff and adding to the node. It's a very, very complex area. And the reality of that is that prioritization is also very rarely used. Everything just gets added with an equal priority. And finally, head of line blocking. And this is really what HTTP2 tried to solve over HTTP1. Rather than waiting for each resource to be downloaded before the next resource can be obtained, we multiplex, so we can get multiple things at a time when we're not blocked on one resource blocking another. That's not the end of the story. So header line blocking essentially is, we've got one slow resource which prevents subsequent resources from making progress. And we've got our HTTP1 example here, with our web page and our style sheets and our script and our image, and each of these get delivered back in sequence to the client over a dozen or so different packets in this example. When we look at this in HTTP2 terms, we're going to start getting that web page. We're going to notice it's got some additional resources and then start requesting those even before the full HTML content's been downloaded. So this is great for user experience. We start making the page look right, getting the images starting to load all at the same time. So we're multiplexing these requests all together in a single connection. But what happens if we lose packet 4? Right, there it is, didn't arrive. If that packet goes missing, the 5th packet's got to arrive, and then we're going to notice that we didn't get packet 4. And what TCP will say is, well, hang on, that's no good. I'm TCP. I guarantee that all these packets should arrive in the right sequence, in the right order. So please retransmit packet 4. So now we're blocked on this packet. Although packet 5 has chunks of a different resource, right? There's different colors in packets 4 and 5. We're waiting for packet 4 again, and then we'll process packet 5. So we're still blocked. We're blocked on one missing packet on TCP. So we've swapped HTTP head of line blocking for TCP head of line blocking. So we didn't go the whole way. And this is what QUIC sets out to do. So with QUIC, by using UDP packetization and for delivering packets, we separate that from the rest of the transport protocol. And what this means is UDP packets can arrive out of order and nobody really cares. If those packets arrive out of order and QUIC knows that they're for different resources, it's totally fine with that. And so if this situation occurs with HTTP3 over QUIC, yes, we need to retransmit the missing packet, but we can carry on processing packet 5 and building that web page for the client in the browser with the packets that we do get for the resources that aren't affected. So that doesn't completely solve header line blocking, but it does mean that we're not dependent on TCP for that. So QUIC to the rescue, yes or no? Primarily it's moving the multiplexing part to the transport. And this has got actually some nice benefits. So the multiplexing in HTTP2 means that HTTP2 is a transport protocol. And really, I would drive this transport bit up into HTTP2. So by moving the multiplexing back into transport, HTTP3 becomes a smaller protocol. It's back to being HTTP and not also masquerading as a transport protocol. QUIC is then a transport protocol that's designed to do the multiplexing. It builds TLS in, as opposed to being a separate layer in its own right, which means it's more efficient and we can do things like session resumption and zero round trip negotiation a lot more efficiently. And it means that we move the reliability of receiving HTTP3 frames for the right resources in the right order down into a transport part and leaving UDP just for the packetization and port numbers and just getting stuff across the internet with IP as before. So what it's really doing is it's moving all the things that we need really into the right places in the overall stack. And at the same time, the semantics of HTTP remain the same. So a get is still a get, Headers are still headers, none of that changes, but the way that we introduce multiplexing and reliability changes significantly. So the separation of concerns is much better aligned with the needs. But of course, nothing's a silver bullet, nothing comes for free, and we have some new challenges to address along the way. So I'll look at a couple of these in detail. I'll touch on the third. Firstly, version negotiation. Now, HTTP doesn't have explicit versioning. There's no handshake with HTTP. There's simply an HTTP GET, and it says what version to use. So, GET, index.html, HTTP1, HTTP2. So how do we know which one to use? How does the client know? Well, with HTTP3 and QUIC, in fact, by the time we've sent a TCP packet, we're kind of too late, right? So how does the client know? How does the browser know whether to use TCP or UDP? So, solved in two different ways. HTTP2 solves this by putting the HTTP2 negotiation into the TLS handshake. So when we make that TLS handshake, the server is able to respond with a hint to say, yeah, I support HTTP2, by the way, and it puts that in its server hello message using ALPN. I'll show you how that works in a moment. With HTTP3, it's slightly different. So when the browser or the mobile app knows that it's talking to a QUIC enabled site, it's just going to send UDP. But when it's talking to a site it hasn't talked to before, it will start with TCP, and there's a way of discovering that QUIC is available and upgrading to that afterwards. So let's look at how that actually works. So here's HTTP2 version negotiation. Client says, let's do TLS over TCP. Server says, great. By the way, here's my ALPN extension, and I support HTTP2. Client says, great, let's do our key exchange. Let's get that encrypted session set up. And now here's my HTTP request for the first frame, get/HTTP2. That's nice and simple. And that, by the way, is why we had to wait a few, a couple of years for all of the SSL implementations, TLS implementations to support this extension to help with negotiation of which HTTP protocol is being used. HTTP3, for a client that doesn't know, right, it says, okay, I don't know you, but I'll assume that you can do TLS over TCP, right? And yep, client server says, yes, I do. And it may or may not indicate it can do HTTP2. Either way, that key exchange happens, session gets set up, and the client sends its HTTP request, this example using HTTP 1.1. Server responds, do it OK, and of course that response is also going to include some headers, and in those headers there's an alternate service header which indicates that QUIC is available for this server on port 443. So now the client goes, oh great, you can do QUIC, here's a UDP packet, let's do another key exchange, another session setup, and the next request I'm going to send you, for style in this case, will be over HTTP3. And of course, the other thing that the client's going to do is remember that this website supports HTTP3 and QUIC, and it will default to QUIC in the future. And here's our second challenge. UDP exfiltration. So let's say I'm a web client, a browser on a laptop in a corporate environment, and I say, here's UDP packet on 443, let's do QUIC. There's a slim chance of that getting outside a corporate network firewall. Right? If there's a proxy, it's going to say, I don't support that either. And in both cases, that UDP packet is going to fall on the floor, and we're going to downgrade to HTTP 1 or 2 as before. Now, we might see web servers start advertising QUIC on port 53, the DNS port, sort of masquerading as DNS. I imagine that'll have limited success. But ultimately, it's going to be a while before we see corporate network infrastructure accepting QUIC traffic for reaching websites on the outside world. So this is going to remain on mobile devices and essentially home equipment talking to websites. So with all that said, Last few minutes here, I want to talk about how nginx provides for QUIC right now. So I said the standard is still being done. We are now taking our development for supporting QUIC and HTTP3 and building that into the nginx open source mainline code, and that's going to be available later this year. It's available right now on our development branch. You can grab this from the website you see here, and you can get a little test to see whether your browser is going to talk QUIC to us or not. The nice thing about moving the different pieces, the concerns of QUIC and HTTP3 into their different areas, is that it's a much more natural fit into the nginx code base. So QUIC is now built into the core for handling connections, and HTTP version 3 is a separate module that understands the semantics of HTTP3. So it's a much cleaner integration, at least compared to HTTP version 2, which bundles those two things together, right? We had to do a little bit of work to extend the Linux kernel using Berkeley packet filter in order to provide this privacy notion that clients are no longer identified by their IP address, right? There's a client ID and it rotates. And when you're talking UDP, that presents some challenges when you're getting packets to the right nginx process for this request. When the client ID changes, we want to make sure that we still carry at least the connection state to the same nginx worker process. But we also have a very kind of natural way of supporting all three HTTP versions. And so what I encourage you here is to start testing HTTP3 and QUIC right now. And you can use the nginx-quic branch to test and show to upgrade existing sites that you have or backend systems to running over HTTP3 and see what the user experience is for those clients consuming it over the internet. So here's a really simple configuration for nginx. I won't go into too much detail, but basically we're listening on port 443. That's our HTTP1 listener. There's some certificates, and we're going to be proxying connections to a backend. Easy peasy. If we want to support HTTP2, we just add the HTTP2 parameter on that listen directive. And now we're listening for both HTTP1 and HTTP2. And this basically also is telling nginx to send back that ALPN extension so that clients can discover and negotiate which version they want to use. And if we want to support HTTP3, well, it's as simple as having another listener, this time on UDP, for HTTP3. That'll accept connections, and also wise to say, here's my alt service header, line 11 here, that's going to go back to that client you saw in the earlier example to say that QUIC is available on this site. If you reach me on HTTP over TCP, you have the option to upgrade and use QUIC instead. And so really it's this simple to take an existing site that's running with nginx and have it working over QUIC and HTTP3. You can do this right now. So to summarize, HTTP1 is never ever going away. It's here for a good couple of decades to come. HTTP2 is the standard for internet-facing web services. That's not going to change in the short term, but it has failed to deliver on its promises, and we're still fixing it. It's still a new protocol. And it's yet to be seen whether HTTP3 and QUIC are going to sort of supersede it altogether. But certainly for the next few years, we're going to see all three versions on the internet all at the same time, and we're going to need to be supporting all three as well. So my advice here is start testing, but expect that HTTP3 and QUIC are really just going to be for services that are going to be facing the internet, and we don't expect to see this entering application network environments anytime soon. So that's it. Thank you for watching and listening, and enjoy the rest of Agility.